We're going to start with Lab 1, which is the skull. And we're going to start with this Duchenne skull, which has been disarticulated, and look at some special characteristics. So sutures are what connect the cranial bones of the skull together. So if we look midline, we have this jagged line that we can see at the top of it, which is the sagittal suture. And then if we look at the suture here that separates the parietal bone from the frontal bone, notice it's on a frontal or coronal plane, so it's called the coronal suture. And then the suture that separates the frontal bone, parietal bone from the temporal bone is on the flattened portions of the skull, so this is called the squamosal suture. And then if we look posterior in the skull, we can actually see that we have a suture that separates the parietal bones and the temporal bones from this bone, which is the occipital bone. And it's called the lambdoidal suture. And if you looked up a Greek alphabet and looked up lambda, it appears to be an upside down U, which is what we're seeing here with this suture. So this demonstration skull allows us to see the sutures pulled apart. Now let's review that on a skull where the sutures are together. And so here are our two parietal bones. So this midline suture through the center of the skull is the sagittal suture. Now interestingly, if we compare the frontal bone on our demonstration skull, notice that there is no suture plane in the frontal bone, and it appears as one bone. An anomaly that we can sometimes see is where there is a suture through the frontal bone. So if you look at this one, this suture continues on through the frontal bone, and it looks like we have two frontal bones. Now, if we look from the side, then we have the suture that separates the parietal bone from the frontal bone. So it's called the coronal suture. As we look from the side, the temporal bone here is separated from the frontal bone and parietal bone by this suture across here, which is the squamosal suture. And then as we look posterior, then we have a suture that separates the two parietal bones in the back of the temporal bones from the occipital bone, and this suture plane we're seeing here is the lambdoidal suture. Now, when you look at some suture planes, particularly in real bone skulls, we can actually see little islands of bone in the suture plane. So notice that this bone is completely surrounded by sutures on all sides. So a bone that exists in a suture plane is referred to as a Warmian bone. Now, next what we're going to do is we're going to backtrack to early development and look at what's going on with sutures during the early development in a fetal skull. So this is a fetal skeleton, and one thing you'll notice is that the sutures are incomplete in the skull. Now there's couple of reasons for that. One is the baby's brain still has to grow, so the skull has to have capacity to grow with the brain. The other is that this provides for a skull that's more pliable to get through the birth canal. So we have soft spots in baby skulls that we call fontanelles, and they typically occur at the juncture of suture planes. So if we look at the anterior aspect of the skull, we have the developing sagittal suture here, and we have the developing coronal suture here. So this big soft spot in the anterior aspect of the skull is called the anterior fontanelle. Now if we turn the skull around, then what we will see is that if we follow the sagittal suture posterior again, then it intersects with the lambdoidal suture developing here. So this point right here is called the posterior fontanelle. So the anterior fontanelle and the posterior fontanelle are actually midline fontanelles associated with the sagittal suture. Now, as we look at the side of the baby's skull, then we have an intersection between the coronal suture here and the squamosal suture here. So this intersection right here is the anterior lateral fontanelle or sphenoidal fontanelle. And as we follow the squamosal suture posterior, then we have the intersection of the lambdoidal suture and the squamosal suture, what we call the posterior lateral fontanelle or the mastoidal fontanelle. These fontanelles will eventually all close as the baby's brain grows and the skull grows. So if you look at a child at about 18 months, their head is largely adult size at that point, and their body is much shorter, so they kind of take on a kind of an odd appearance at that point in time. Our next special characteristic of skull we're going to look at are called sinuses, and sinuses are hollow spaces within a bone that lighten our skull. So when we're looking at sinuses, there are sinuses associated with our nose. So these two orange bones are called the maxilla bones, and these bones are hollow inside. This bone above it here is the frontal bone, and this bone is going to be hollow inside. And then when we look at the floor of the cranium, this yellow bone is the ethmoid bone, and this red bone is the sphenoid bone. And so the ethmoid bone is hollow inside, and the sphenoid bone is hollow inside. Now the only way we can see these sinuses is actually to cut bone. So in this demonstration skull, all the sinuses have been cut open. So if we look at the maxillary bone that forms your cheek, you can see that this is very hollow inside there, and there's a hollow space. So that's the maxillary sinus. As we move above the eye, this would be the frontal bone, and as we can see, if we cut that open, it's hollow as well. And if we look midline, we can actually see the hollow nature of the frontal bone here. Now, as we move back from midline, this is where the ethmoid bone would be. So this hollow space in here that's kind of broken out of the skull is where the ethmoid sinus is located. As we go back, this depressed area is on the sphenoid bone. So this hollow space associated with that depressed area is the sphenoid sinus. So when we're looking midline, in line with our nasal passage, we have frontal sinus, ethmoid sinus, and sphenoid sinus as three of our paranasal sinuses. And then if we turn the skull like this, our fourth paranasal sinus is our maxillary sinus. Now, behind your ear, you have a projection that is called the mastoid process. And this mastoid process is hollow as well. So if we cut this bone away, as in this demonstration skull, then we'll see that this was a hollow area inside the skull as well. And so this is called the mastoid sinus. Now it is not a paranasal sinus because it's not associated with your nasal passage. So the next thing we're going to look at are blood sinuses. This is a funny place in English where we have the same word sinus, where one was a bone sinus, but a blood sinus is actually a depression where a blood vessel set. So it's called a sulcus. And so blood sinus sulcuses are the impressions of veins that were draining the brain. So if you look at the inside of the cranium, following the sagittal suture, there's a depression that you can see right here. And so this is called the superior sagittal sulcus, which contained a blood vessel called the superior sagittal sinus. Now, blood flow in this is from anterior to posterior as we're moving backwards. And so if we look at the back aspect of the skull, and I'm going to turn it so we can look at it like this, then it subdivides right here. And so what we can see is we have a sulcus that is on this plane, which is a transverse plane. So this one here is called the transverse sulcus, which we would see on the inside of the occipital bone. Now, as we move upward, then we run into this ridge in the skull. And so the blood vessel actually flows into the ridge, down along the ridge, and out through a hole at the bottom of the skull. So where we see the sinus curving along this ridge to the jugular foramen here, it forms an S. So the sulcus we see in here is called the sigmoid sulcus. And then eventually the sigmoid sulcus is going to become continuous with this hole called the jugular foramen. And eventually the blood vessel is going to be renamed the jugular vein as it exits this hole. So the rest of the lab is identifying bones on the skull. So what we're going to do is we're going to start with a colored skull so that we can see all the bones. And then once we've looked on a colored skull, we're going to go back to a regular bone skull and look at the same bones. So my purpose here is just to show you where the bones exist. So as you're going through your lab, the first bone you're going to look at is the frontal bone, which is this bone that we see right here. The second set of bones on your lab you look at are the parietal bones, which are the two green bones that we can see on the skull. As we turn the skull around, then the blue bone that we see here is the occipital bone on the skull that's posterior. As we look at the sides of the skull, then we'll notice that we've got this kind of brownish bone, which is our temporal bone. And so we can see the temporal bone on this angle. We can see that the temporal bone rolls underneath. Now also we can open up the inside of the skull and we can see that the frontal bone forms part of the inside of the skull. The parietal bones form part of the inside of the skull. The occipital bone forms part of the inside of the skull. And then our temporal bones form part of the inside of the skull. And then internally, a bone that connects with all the bones we just talked about is this red bone, which is the sphenoid bone. And we're going to look at a number of characteristics on the sphenoid bone as well. Just anterior to the sphenoid bone is our ethmoid bone, the yellow bone here. And notice that with our yellow bone, we can actually see it in the orbit of the eye, and we can see it in the superior aspect of the nose. Just like our sphenoid bone that looks like a butterfly on the inside can be seen behind the orbit of the eye and can be seen associated with the posterior nasal passageway as well. So as we move below that, then the bone that forms your bottom jaw here is your mandible. And so we can see the mandible here. And the bone that forms your upper jaw is the maxilla, which is the orange bone that we see here. And we can see the maxilla as part of the orbit of the eye, and we can see the maxilla as part of the roof of the mouth. Now we have two little bones that form the anterior aspect of our eye, which are called lacrimal bones. We have two small bones that form the posterior portion of your hard palate, the pink bones we see here, which are the palatine bones. We have two small bones that form the bridge of our nose, our nasal bones. And we have one bone that forms the posterior aspect of the septum of the nose, the white bone we're seeing in here, which is our vomer. And we have one purple bone here that forms the high part of our cheek, which are the zygomatic bones. And so those are all the bones. So sometimes it works to use this colored skull to figure out where the bones are, but you really need to know all this material on a non-color coded skull. So we will go through everything that we just showed you with a regular skull.